All right, let's play with some invertible facts. So I know that P is invertible, and I want to solve for B in terms of A. So let's do this. So first off, I'm going to multiply both sides by P inverse on the left. So P inverse A, P inverse P, B, P inverse. So these two here, this P times P inverse makes a 1, right? Makes an I, and then times B, P inverse, and so I still have this P inverse A over here. So I, meaning the identity matrix, we're 1. I don't need to carry along, right? So then I can multiply both sides on the right by P. So I'm just going to put it in a different color here just to make sure that we're making sure, I want to make sure you multiply on the correct side. So if I multiply on the right by P, then these two make an I, or 1 in matrix land. So then I get P inverse AP. All right. So here we go. So here I have C inverse A plus X B inverse equals I. Okay, so A, B, and C are invertible. So that means I'm allowed to multiply by its inverse, and I want to solve for X. So it's not any, it doesn't have to be this, but I'm just going to start by, I'm going to carry this along. I'm going to start by multiplying, whoops, I'm trying to do it in green here, multiplying on the right by B. Then this makes a 1, so I have C inverse A plus X equaling just B. All right, now I want to multiply on the left by C. So C and C, let me carry the rest of it along. Okay, so I multiplied on the left by C, so now I'm left with A plus X is equal to C times B. So then to solve for X, I'm going to say the matrix CB minus A. All right, so moving on to this next one, a little more challenging. So I know that A, B, and X are square, and they're invertible. And that, A, B, and X are square matrices, and that A, X, and A minus X are invertible. Okay, so here I have A minus X inverse, and that's invertible. X is invertible, that's good. And B, I do not know is invertible. All right, because it doesn't say B is invertible. So how can I explain why B is invertible? Well, I'm going to take this here, and I'm going to write it down again. All right, and now I'm going to multiply on the left by X on both sides. So this gives me X, A minus AX inverse. X and X inverse, right? They're invertible. Those are go away to 1, and so I'm left with B. So what I have is B is a product of two matrices. So B is a product of X and A minus AX inverse. And what do I know about X? X is invertible. And do I know that this is invertible? I do, since A minus AX is invertible. That means A minus AX inverse is invertible. So what I have here is that I have B is a product of invertible matrices. So if it's a product of invertible matrices, that must mean B is invertible also. All right, let's move on to this next one. All right, so now I want to solve for X from this equation right here. So I'm going to take this equation, excuse me, take this equation and just write it down again. A minus AX inverse equal X inverse B. Okay, so now from here, I'm going to take the inverse of both sides. Take the inverse of an inverse. That gives me A minus AX on the left-hand side. And you remember how you take the inverse of a product? You switch the order. So I get B inverse, and this is X inverse inverse, which is X. All right, so now remember I'm solving for X. So let's make this A. Then I'll have AX plus B inverse X. Okay. So I want to solve for X, so I've got A equal A plus B inverse X. I'm going to pull on the right-hand side, I'll factor out X. Okay, so I need to know that this is invertible. I know the product of invertible matrices is invertible, but I don't know about adding together or subtracting invertible matrices. So let's look at what I've got here. So here I have A. So A I know is invertible. A is invertible. And it's written as a product of, it must be invertible matrices. Because if A is invertible, then this product must be invertible. So that must mean that A plus B inverse is invertible, and we already know X is invertible. Okay, so since A plus B inverse is invertible, now I can multiply both sides by A plus B inverse. So A plus B inverse on the left-hand side times A equals, and I'm just going to write it just so you see, A plus B inverse. Oops, I meant to put inverse out there. A plus B inverse X. So here I have A plus B inverse inversed A equal, and these two multiplied by 1, so I get equals X. That was kind of challenging. All right, looking at this next one. So explain why the columns of a square matrix are linearly independent when A is invertible. So if A is invertible, must mean that it is row equivalent. To IN, right, the identity matrix square n by n. So if it's row equivalent to IN, then it must have a pivot in every column. So columns of A are linearly independent. All right, let's stop there.